Hey everybody, we're back and we're talking about trigonometric functions and the unit circle. Today we're going to learn how to identify a unit circle and describe its relationship to real numbers. So here's what we know about a unit circle. So first of all, here's our important vocab. A unit circle, first of all, it has a radius of 1. I can't write. So of 1 unit, well, that's why it's called the unit circle, not units circle. And it has a center at the origin, 0, 0. And it's given by the most standard circle equation, x squared plus y squared equals 1. The word periodic means it refers to functions that behave in a repetitive or cyclic manner. That basically means that it over time it repeats itself somehow. And lastly, a period is the distance or some units distance of c that it takes for a function to repeat the cycle. All right, so let's talk about the unit circle specifically. So a couple of quick things we need to know before we get into the nitty-gritty is that as the real number line is wrapped, so think about a real number line. It's wrapped around the unit circle. Each real number t corresponds to a point, otherwise known as x comma y, on the circle. Okay? And the real number 2 pi corresponds to the point 1 comma 0. So we've kind of been learning about this already, where if we call this the x and y axis, and let's say this is a value when x is 1, y is 1, the distance from 0 to this point is -1, or a distance of 1, but we call that -1. And here's where y equals -1. And we have a circle, okay? We have a circle, and we call that the unit circle, where the real number, so remember we said that the initial point is 0 degrees, but it also comes back around and is 2 pi. Corresponds to the point 1 comma 0. So this point is 1 comma 0, because if we were to graph that circle, we'd say, okay, that's on the point 1 comma 0. And each real number t also corresponds to a central angle that we call theta, or some other variable like t, in standard position, whose radian measure is t. So when we say t, that means it has a radian measure, some value of t. With this interpretation of t, the arc length formula, which we learned about, S equals r times theta, with r equals 1, indicates that the real number t is the length of the arc intercepted by the angle theta in radians. Okay, so if this is our angle, let's just say theta, then the arc length that it has, we call that t. Because this is a unit circle, though, that arc length, that we would normally say is the radius times theta, because the radius is 1, then in this case for a unit circle, theta equals t. Because if radius is just 1, we're just multiplying it by 1. So let's talk about the trig functions. So this word sine is abbreviated and with these 3 letters, and we pronounce that sine. Cosine is abbreviated as cos or cos. Tangent is abbreviated as tan. And then we have the other 3 6 trig functions. The 3 most common are sine, cosine, and tangent. Cosecant is abbreviated CSC, secant is SEC, and cotangent is COT. I want you to keep in mind that we can come up with these 6 trig functions with a couple of different ways. And you've probably seen this before. Keep in mind that when this is the x-axis and the y-axis, okay, remember that it's a circle with a radius of 1. So if I draw angle theta or t, and we know this radius is 1, this point right here, we call that x comma y, represents that this bottom portion along the x-axis is the x value, and this vertical portion from the x-axis up to the point is the y value. So hopefully you remember the acronym SO, CA, and TOA. And this refers to, from this angle, that this is the opposite side, the adjacent side, and the hypotenuse side. Okay, so the sine of t, we say from angle t, we say sine is the opposite over the hypotenuse. So we say O over H, and in this case, the opposite side is y, and the hypotenuse is 1, which in that case is just y. Let's look at the next one, the cosine. We know cosine equals to the adjacent over the hypotenuse side, which is adjacent is right along here, which is x, over h is 1, so that value is just x. Hold on to this piece of information that sine equals y and cosine equals x. That will come in handy in just a little bit. Let's look at tangent. Remember, tangent is t. Tangent equals opposite over adjacent, so opposite over adjacent. So the opposite side is, again, y, over the adjacent side is x. Now, cotangent comes from tangent in that it's 1 over the tangent of the angle. So 1 over anything is just the reciprocal. So the reciprocal of tangent that is normally opposite over adjacent is going to be adjacent over opposite, which in this case is the reciprocal of y over x. So that's x over y. So if we know tangent, we automatically know cotangent is its reciprocal. Same thing with secant. Secant is the reciprocal of cosine. Now, with secant and cosecant, sine and cosecant, I just want you to remember S goes with C goes with S. Never the two go together. S does not go with S, C does not go with C. So if 1 over cosine, that just means the reciprocal of cosine, which is the hypotenuse over the adjacent, which is the reciprocal of A over H. And that's also the reciprocal of x over 1, which is 1 over x. And last but not least, our cosecant is the reciprocal of sine, which we know is the reciprocal of over h, which is h over o, which is 1 over y. So keep those in mind when we're building these functions. The cosecant function is the reciprocal of the sine function. The cotangent function is the reciprocal of the tangent function like we said, and the secant function is the reciprocal of the cosecant function. Okay, now it says to complete the following table to show how this corresponds between these two numbers. I'm going to show you this, but instead of doing it in a chart, I'm going to show you on a unit circle. So let me show you this. That here's a unit circle, okay? And let's go ahead and fill out our degrees. So we know this value here on the x-axis is 0 degrees. We know this up here is 90 degrees. This over here is 180 degrees. This down here is 270 degrees. And then we come back on 360 degrees. Now, when we're filling that out, remember, we know that there's equivalent values in radians. So I know 0 degrees is the same thing as 0 pi radians. 90 degrees is the same as pi over 2 radians. 180 degrees is the same as pi radians. 270 degrees is the same as 3 pi over 2 radians. And then coming back to 360 degrees around the circle is 2 pi radians. We're going to go ahead and cut these just like we did before and convert them. Let's go ahead and cut each of these in half. So I'm going to use this middle line here. I'm going to highlight it with green. So these green lines are exactly half of each of the quadrants. So half of pi over 2 is really pi over 4. So we know in radians, and I'm going to put this in dark green, in radians that's equivalent to pi over 4, and in degrees this is 45 degrees. Now keep in mind, every time I've got that rotation of green, so from here to here is 45 degrees. From here to here is another 45 degrees, that's 90 degrees. 90 plus 45 up to this angle is 135 degrees. Or we say 0 plus pi over 4 plus pi over 4 again is pi over 2 plus another pi over 4 is 3 pi over 4. So we can see, what is going on? We can see that as we add onto itself, we're going to see pieces of those pi over 4. I add another 45 degrees and I get 180 degrees or 4 pi over 4, which is just pi. Add another 45 degrees and we get 225 degrees or 5 pi over 4. Add another 45, we get 270 degrees or 6 pi over 4, which reduces to 3 pi over 2. Add another 45 degrees and we get 315 degrees or 7 pi over 4. And then add another 45 degrees, we get 360 or 2 pi. Okay, let's go ahead and label the rest. We're going to do this one in pink. So now that we're doing that, we're going to go ahead and highlight. I'm showing you these lines right here are cut into thirds. So here's a third of a quadrant. Here's another third of a quadrant, and so on. And I'm going to show you what we're going to do with this in a minute. So each of these is another third. So I know from here to here that 0, a third of a quadrant is 30 degrees because a third of 90 is 30 degrees. So we're going to say this is 30 degrees. Add another 30, that's 60 degrees. Add another 30, that's 90. Add another 30, that's 120. Add another 30, that's 150. Add another 30, that's 180. Keep going in that pattern. 240 plus 270, that's right here. 270 plus another 30 degrees is 300, plus another 30 is 330. Now, you can also think of these second 30 degrees as increments of 60. So I can also divide 60 to 180 by saying a third of pi this way. So let's go ahead and rename these pieces of pi. So I know 30 is really pi over 6. this, from here to here, pi over 6 plus pi over 6, that's 2 pi over 6, which reduces to pi over 3. Okay, add another 1, 2, pi over 6, 3. Pi over 6 is pi over 2. 4 pi over 6 reduces to 3 pi. 4 pi over 6 is really 2 pi over 3. And then 4 pi over 6 plus 1 more is 5 pi over 6. So you can see that we have this pattern of pi's over 6 that reduce to pi's over 3 every so often. And then we're going to keep going with that pattern. Pi plus pi over 6 is 7 pi over 6 plus pi over 6 is 8 pi over 6, which reduces to 4 pi over 3. Add that again, we get 270 or 3 pi over 2. And then we end up with 8 pi over 6, which is really, pardon me, 8 pi over 6 is right here. 9 pi over 6, 10 pi over 6, which is really 5 pi over 3. And then we end up with 11 pi over 6 here. Whew. So we've measured it all out. We've got all of our angles, all of our radians. Now we're ready to label what's what.